Alright, on this problem, you're told you have a 1000 ohm resistor and a 500 ohm resistor connected in the circuit as shown, and there is a 30 microfarad capacitor connected parallel to the 500 ohm resistor. And the first thing you want to do is measure the current and the voltage in the circuit. Let's see here. The first thing you want to do is calculate the current in the 500 ohm resistor. Excuse me, I got ahead of myself. So to calculate this, what I would do is to start with a VIR chart. So, you have, let's say, resistor 1, resistor 2, and the total. Well, resistor 1 is the 1000 ohm resistor, resistor 2 is the 500 ohm resistor, and the total resistance is going to be, well, these two are series, so it's going to be 1500 ohms. Your voltage is 12 volts. So if I want to solve for my current, 12 divided by 1500 gives me a current of 0.008 amps. And since these 1 and 2 are series, I know the current's the same across all of them, so I can say 0.008 amps. 0.008 amps. And then I can even complete this with solving for my voltages by multiplying V times R. I times R. This gives me 8 volts here and 4 volts there. So the first thing you're asked to figure out is what the current in the 500 ohm resistor is. Well, it's going to be the same as the current in the entire circuit, which is 0.008 amps. Now don't forget, there is a capacitor there, but you're told that this right here is reached a steady state value. And what that means is that the capacitor is fully charged. And if the capacitor is fully charged, then there is no current that flows through it. Now the next thing you're asked is figure out where could you measure the current in the 500 ohm resistor. Now the current has to be measured in series with the resistor. So to make it in series with the 500 ohm resistor, I could put it either at the bottom or I could put it either at the top. Either one of those two values will be fine. But to measure current, anything that goes through the 500 ohm resistor needs to go through one of these two ammeters. And you only need to draw one, so we'll just leave it at the bottom. That'll work. The next thing you're asked to draw is to find the voltage across the 1000 ohm resistor. Now this is just like we did in the lab. To find the voltage, you want to draw it as parallel, because if I just put a voltmeter series in the circuit, it would not read the voltage because it wouldn't have any difference to look at. So what you really want to measure is the difference between each side of this 1000 ohm resistor, so that it needs to be in parallel. Alright, next thing you want to know is calculate the charge stored on the capacitor. Now, you know that charge on a capacitor is equal to Q equals CV. So, to measure this charge as Q, we need to know what the voltage across this capacitor is. And since this capacitor is parallel with the 500 ohm resistor, the voltage on the capacitor will be the same as the voltage on the 500 ohm resistor, which we measured to be 4 volts a while ago. So if we plug it in, Q equals 30 times 10 to the negative 6 farads, that's microfarads, and times 4 volts, we'll get the charge of 1.2 times 10 to the negative 4th coulombs, just by plugging in our value. Alright, next thing we want to know, what is the power dissipated in the 1000 ohm resistor? Well, power is equal to IV. So we know the current in the 1000 ohm resistor. We solved it right there. So it's going to be 0.008 amps. And the voltage across that resistor is going to be this, kind of what the voltmeter we draw through earlier will measure, which is 8 volts. So that power is going to be 0.001 watts. Wait a minute. I think I have a decimal wrong. Wow, yeah, that's not right. Hit the wrong button on the calculator. Hit the dividing instead of the multiplying button. Try 0.064 watts. That's better. Alright. The next thing says that the capacitor is now discharged and a 500 ohm resistor is removed and replaced by a resistor of greater resistance. The circuit is then connected. The currents are then allowed to come to their same steady state values, or their new steady state values, and it asks is the charge of the capacitor greater, larger, or smaller than it was before. So we have to start by looking at the charge on the capacitor, which is Q equals CV. Now our capacitance doesn't change, but our voltage might. So we go back and look at our circuit. If we change this value of this capacitor here to be some larger value, then what it will do is it will change this total resistance here, which will drop this current. And when you remultiply all these out, the lower current will make a smaller voltage on 1 ampere. And according to Kirchhoff's loop law, these two voltages here must add up to equal the total voltage, which is 12. So if voltage 1 drops, then voltage 2 on the what was a 500 ohm resistor was now some larger resistor, that voltage must go up. So when we look at our charge formula, this voltage here goes up. And since C stays the same, our charge must be larger. And that's because the voltage is greater according to Ohm's law and Kirchhoff's law.